this presentation, we will demonstrate another feature of our decentralized application, and that is a task. So before we do so, I will give more context of how we currently think about tasks and how they're implemented. So if profile was the aspect of the application that defines your identity, tasks define the activities that you can do with your profile. So tasks are basically the things that you can perform or create. As an incentive for completing tasks, you get increased reputation, and also you get a cryptocurrency reward. The simplest way you can think of tasks is as a unit of work. So what is the unit of work that we have within the blockchain to represent what people need to do or what they can do? The characteristics of a task. So what characterizes a task? In this initial version of the product, task is defined by three things. The first one is requirements. So what are the task requirements? What needs to be achieved? The next one is budget, how much the task is being valued. And the third one is a deadline, when the task needs to be completed by. So task has to be defined by in terms of these what, how, and when questions. In regards to tasks, there are two types of users. So there's initiators and volunteers of tasks. Initiator is the user who initiates the tasks and creates the requirements for the task. And volunteer is the user who volunteers to undertake the task. The task can have three status types. So it can be in type created, in progress, or closed. Some more details regarding tasks. The first is that tasks will be ephemeral or short-lived. So once tasks are completed, they will be removed from the blockchain storage. Another detail is that when task is created, an escrow agreement is formed between the task initiator and the task volunteer. So what this means is that when the task is created, the budget amount is moved to an escrow account and funds are locked there until task is completed. So when the task is completed, those funds will be distributed back to the volunteer who completed the task. In the case that the task is not completed, funds are returned back to the task initiator after the deadline. What are the tasks actions that we can perform? So here on the right side, you can see the two type of users. So we have initiator and volunteer. The initiator is the one who creates tasks and is able to remove tasks. And the volunteer is the person who is able to start a task and complete the tasks. So let's move to the demo to see how this works. So again, we have the same screens. On left, we have the functions, what we can do on the blockchain. And on the right, we have the events or the queries, the data that comes back from the blockchain. So what we want to do with the existing profiles, so let's say Alice is the one that wants to create a task. So for that, you'll go to the task extrinsic. And here we can have we see the functions that we have on a task. So a person she wants to create a task because the task does not exist yet. Here on the right, we can query. So we can go to task and we can query the number of tasks that exist currently in the system. So as we can see, the number is 0 because we have not created any tasks yet. So Alice wants to create a task where she wants to, create a new substrate palette. She has a balance of 77,000. And the deadline in terms of blocks, let's say it's in the next 1,000 blocks we need to create to finish this task. So what Alice does is she wants to submit this transaction to the blockchain. She wants to create the transaction. And basically the transaction was created. So we can see the notifications here. If we query the number of tasks, we can see that this task was created. So if we want to query the exact task, we can just query the blockchain and we can see the data for the task. So we can see the initiator, the current owner, the requirements, so create substrate palette, and the deadline. And this is the hash of the task, so how the task is uniquely identified. We want to copy this. And now let's say another user of the blockchain wants to complete the task, so they want to create a substrate palette. In our case, let's say that person will be Bob, so he wants to go to a task and he wants to start this task. What he has to do is he has to input the hash of the task and he has to submit a transaction. So we can see the transaction happened, and if we query this transaction by the person that owns it, so now we can see that Bob is the one that owns the task. So if we query for Alice, we can see that she no longer owns the task, so she has an empty list of tasks. So basically, because Bob started working on the task, he took ownership of the task and he was the volunteer who undertook the task. So let's say some time passes, Bob develops the tasks and he wants to complete it. So for that he'll go to an extrinsic called complete task. He'll submit his task ID and he'll sign and submit the transaction. So now if we query, let's query the blockchain without for Bob. So what we want to do is, okay, let's see how many tasks there are. There's still one task. We want to query the exact task to see the details of the task. So this is the task that we have, and we can see that the status is closed. So the volunteer was Bob with the one set of key, and the initiator was Alice with a set of key. We can see the budget and the deadline. So what happens next is Alice will log in with her account. She will see the result of the work, and let's see, she wants to accept and remove the work, the tasks. So she puts the ID, she goes submit transaction, so the tasks was successfully removed. And if we query again the tasks, we can see that the task doesn't exist. So if the task count should be back to 0. So once the task is performed, we no longer store the data for the tasks because he was successfully accepted by the person who created it. So that's about it for tasks. And for DAOs, please continue to the next demo. Thank you.